Hello everyone, let's look at this integral today. This integral is 3 minus the square root, and so if you just look at the integrand, it feels like it's going to be in Trig problem, but because it's a definite integral, then we probably don't even need to use Trig. We can actually just interpret this geometrically. We just graph the function and see what region that it's bounding with the x-axis. Okay, so let's take a look. So first, regarding graphing this function, there are different ways to do it. One way is to just focus on graphing this one. As you can see, that's the square root of 4 minus x squared. And what is that? That's actually a semicircle. Okay, that's a semicircle here. And then, or you can simply just graph the whole thing, which is what I'm going to do here. And so what we're going to do is that we are just going to just look at that. Okay, so there is a semicircle. And because there is a minus sign in front of the square root, that's actually the negative square root. Okay, in that case, you are going to get the bottom half of the circle. And the 3, it's really just telling you that you're going to do a transformation. So let's just get started right now. So first, I'm going to write down the function. The function is y equals 3 minus the square root of 4 minus x squared. And then if you rewrite the function, then it's going to look like this, minus the square root of 4 minus x squared, and then plus 3. And so do you see what's going on here? Let's just do some labeling right here. And as I have pointed out, this would actually be giving us a semicircle, right? A semicircle right here. The minus sign tells you that it's going to be the bottom half. I'm going to just annotate that later, but let me just write down the radius and the center first. So regarding the radius for the semicircle is going to be 2, as you can see, because we have a 4 here. And then also, what about the other one? The other one is going to be the center that we want to write down. The center is going to be at the origin. Okay, and so now what about um, what about what about this minus sign? This is the bottom half of the circle. Bottom half. Okay, I think that's good enough. Okay, and then you may say, what about the 3? The 3 is actually it's really just a transformation of this bottom half of the circle. Because you are just adding 3 to the whole function, what we are doing is that we are going to just vertically move the semicircle up 3 units, right? So it's a vertical translation, or you can just say that that's a vertical shift, and then 3 units up. Okay, so if you just look at the circle here, it's actually going to look like this. Because the radius is 2, right? And the center is at the origin, so the circle is going to look like this. But because we have a plus 3, so we are going to move this whole graph 3 units up. So we're going to count 1, 2, and 3. So the point is actually right here. Okay, so the point is right here. And then now you just count this one. This one is another key point here. We count 1 and 2 and 3, so we get this point here. And then same thing here on the other side, so we get the point located here. And then you're going to graph that semicircle. Okay. And then you don't really need this bottom portion. I'm just going to erase it right now. So now we have the function graph. Okay, but of course we also do not need this portion right here because the integral is only going from 0 to 2. So what are we trying to find here? We are finding the area of the region. Okay, so we are finding the area of the region that's bounded by this portion of the curve, this vertical line right here, and then also the y-axis, right? This is x equals 2. That's x equals 0. And then also we have the y equals 0. So this is the region that we're looking at. Okay. Now you may say, how do we find the area of this region? The idea is simple. We don't really have a formula for this for the area of this region, but we can actually find the area of this portion right here. Okay, so let me just show you what's going on here. We do have the formula for finding this blue region right here. That's really just what? That's really just a quarter of a disk, right? So we can find its area, and all we need to do is to find the area for this rectangle, subtract the area of this quarter of the disk, and then we get the area of this region. Okay, so let's do that. So we are going to find the area for the whole rectangle. The area for the whole rectangle, then it's going to be 2 units for the width, right? And then the length, it's going to be, what do we get here? It's 3 units, right? So what we have is that the area for the rectangle is going to be what? It's going to be 2 times 3. And so we're going to get 6. Is that good so far? Now, what about the quarter of the circle? So the area for just the quarter of the circle, right? This region right here, how do we find that? That's going to be what? That's going to be a quarter of the circle, so 1/4 pi r squared, right? And then what is the radius? The radius, as you can see, the radius is 2. So you're going to plug the 2 in there, so you get 1/4 pi times the 2 squared. So now if you just simplify this, we get 1/4 times 1. Well, actually, it's 1/4 pi times 4. And then you can see that we actually will be able to cancel all the 4s, right? So we are going to be getting, what is that? That's going to be pi. Okay, so now finally we are going to find the area for the integral, right? So for the integral, 3 minus the square root of 4 minus x squared dx, that's equal to the area of this this region right here, right? And then how do we find that? It's actually the area for the rectangle, subtract the area for the quarter of this, then we are going to get the final answer. In this case, it's actually simple. It would just be what, 6 minus, what did we get here? We get pi, right? 6 minus pi. And then we are finished. So the value for this integral is 6 minus pi. See that it's actually quite easy to do. If you have to go with the usual way to do it, you've got to find the antiderivative for this function, which will require you to use trig stuff for this portion of the function. And then after that, you got to use fundamental theorem of calculus, plug in the 2, plug in the 0, and then you figure out the answer. But doing it this way, it's a lot simpler. Okay, so that's it for this problem. To help me make math learning available to everyone, please share my videos to others and subscribe my channel. It will give me support to make more videos. Let's work together to help students and children learn math more easily.